Hi again, welcome back. Today the topic is differential equation. What is differential equation? Generally a equation is said to be x plus y. If it is a differential equation means d by dx of x plus y. So we need to add d by dx. What is d by dx? D by dx is nothing but differential coefficient. So the differential equation will contains differential coefficient, that is d by dx, or else d by dy, dou by dou x, dou square by dou x square. Okay, so likewise there should be an differential coefficients. So this differential equation is divided into ordinary differential equation and partial differential equation. Okay, there are two types, ordinary and partial differential equations. So let's see that. Ordinary means what? With respect to one variable. The differential coefficient with respect to one variable means it is ordinary differential equation. These are the differential coefficients. D by dx means with respect to x only, but here dou by dou x means with respect to x, but the another constant y will be taken as constant. Okay, so we can use both, means we can use this dou by dou x for both x, y, z for more variables, right? So if it is dou means it will be partial differential equation. If it is d means ordinary differential equation. Okay. So the order of differential equation, we need to find the order means what? Order of highest differential coefficient. Let's take this. Comparing these two, this is the highest coefficient. Okay, highest differential coefficient. What is the order here? The order of highest differential coefficient. So the order is 2. Here the order is 1. Here the order is 2. Degree of differential equation. Degree means power. Okay, like if we got a degree, we will get a power, right? So degree of differential equation means power. Power of highest differential equation provided the equation should be free from fractional powers. So the equation should be free from fractional powers. If they have given in fractional means we need to convert it. And then we need to take the power of the highest differential equation. So highest differential equation is order. So the power of this one is degree. Okay. So let's see some examples here. 1 plus dy by dx the whole square, right? The whole part 3 by 2. Here you can see that this power can be separated. So the order you can see here, whole square means what? This is nothing but d square y by dx square. Okay. So the order is what? 2. And if we put this power inside means 2 will get cancelled, right? So the degree will be 3. You can see here in both cases the order is 2 and the power is 1. Okay. So this is the thing. And then what is radicals? Radicals is nothing but if the power of this differential coefficient. Okay, so the power of this differential coefficient will be the radicals, like 1 by 2, 1 by 3, only the fractional powers. Okay, the powers are in fractional, means it is said to be radicals. Fractions means what? Fractions means derivative should not in denominator. Fraction means the derivative should not be in denominator. For example, if it is said to be x square which is equal to y by dx. Okay. So we need to convert this denominator y by dy means we need to convert this denominator to upper. So the derivative should not be in denominator, that is called fractions. Let's see some sum here, like we need to find the order and degree. Okay, so they have given one equation here, d square y by dx square the whole part 2, which is equal to x plus dy by dx the whole part 3 by 2. Okay, yes. So we need to find the power. You can see here the highest degree is what? 2. Sorry, the highest order is what? 2, because this is first derivative, this is second derivative. So the order is 2. So we have got the order. But see here, we need to find the degree, right? This is the highest order. Highest order has the power 2, but here it is fraction, so we need to change it. If we change the power means this 2 by this is in denominator, it will come to numerator. So if it has come to numerator means it will become 4, right? So the degree is 4. That's it. Next sum, dy by dx, which is equal to x plus e power x by dy by dx, right? So the differential coefficient should not be in denominator, right? So I need to change it. For that purpose, what I need to do, just multiply this term here, here, here. Like if I multiply this term here means it will get cancelled. Here means dy by dx. Here means dy by dx the whole square. Okay. So this is the thing I have written here. After that you can find the order and degree. What is the highest order here? First derivative. Okay, 1. What is the highest order power? Is 2. So the degree is 2. Okay. How can we form the differential equation? Okay. How can we form the differential equation? Eliminating AB. AB is what? Arbitrary constants. N number of AB constants are eliminated, which is equal to nth order of resulting ordinary differential equation. What is this? N number of AB means the AB can be n number of times, okay, or eliminated. So how many number of ABs are eliminated, which is equal to that numbered order of resulting differential equation. So the resulting ordinary differential equations order will be that number. Okay. So let's see one sum. Means they have given y which is equal to ax plus by. So they have given two constants here and we need to reduce this equation to differential equation. So what is the first step? First derivative, then second derivative. From second derivative you have got b value. Okay. So first derivative and then second derivative I have got b value. Just substitute this b in the first derivative. I will get a value, right? Substitute both the values in the original equation. After reducing it, I will get the differential equation. So simple. An equation, first derivative, I still have two constants. Second derivative, I have only one constant. So I have found that constant and substitute in this equation, I will get a. Why it is not substituted in this equation? Because this is dead easy, right? Here they have square and all. But here it is not. So it is easy. So I am just substituting b here. And then I have got a here. Substitute both the values in y. And simplify it. You will get the last equation. What is y double dash? D square y by dx square. So the same applies here. So this is an example sum. Okay. Next you can see here y, which is equal to x c into x minus c the whole square. First derivative, I still have the c. Next, first derivative, I just simplify it. Like, I will say that c into x minus c the whole square. How can I differentiate it? For differentiating x square, in Tamil, power முன்னாடி கொண்டு பவரில் ஒன்று மைனஸ் பண்ணும். Take the power to the front and minus 1 to the power and then base differentiate பண்ணணும். So, I have to differentiate x. So, for x minus c the whole square means I just bring the power before. Power முன்னாடி கொண்டு வந்தாச்சு. Then, powerல ஒன்று minus பண்ணும். So, 2 minus 1. Afterwards, base differentiate பண்ணும். If I differentiate this base means what will come here? Only 1. Right? So, this is the thing I have written here. C into power முன்னாடி கொண்டு பவரில் ஒன்று மைனஸ் பண்ணி பேஸை differentiate பண்ணும். So, bring the power before and minus 1 to the power and then differentiate the base. I have got one equation. I no need to find the y double dash because there is only one constant, right? So, one derivative is enough. Okay. Then, y by y dash, which is equal to, I need to divide these two equations. After that, I will get x minus c equal to 2. Okay. You can see here that x minus 2 equal to 2. X minus c by 2. Okay. So, this is the equation I have got. Then, I need to find the c value here. So, just replace all these things, you will get the c value. Substitute the c values in this equation and then still simplify it. Take LCM here. Like if I take LCM means x y dash minus 2y. Right. Okay. By y dash into, if I square means if I take the square 4 y square by y dash square. So, there are 3 y's here. So, I am just taking this 3 y's here. Okay. Taking the 3 y's. Y dash square, y dash. So, y dash cube. I am just taking here. And then, I need to multiply. Like, I am just taking here. And then, I need to multiply all these things. I will get y dash square, y dash cube, which is equal to 4xy y dash minus 8y square. Let's see the next sum. Y, which is equal to a cos x plus b sin x. Okay? Yes. And y dash. There are two variables, so we need to find up to y double dash. Y dash is what? A into cos x. If I differentiate cos x, it will be minus sin x. But sin x, it will be cos x. Just differentiate it. Again, we need to differentiate it. So, y double dash, which is equal to minus a into sin x means cos x. Cos x means minus sin x. Right? So, if I take the minus means outside, I will get the same y here. So, y double dash is nothing but minus of y. So, this is the equation. I no need to put a lot of things. Just I need to eliminate x, a, b, right? So, I just eliminate it. That's it. And the next questions. X minus h the whole square plus y minus k the whole square, which is equal to a square. What is the thing here? They have given 3 constants. So, first we need to find with respect to x. I just need to differentiate it with respect to x. Okay? Okay. So, let's see that. Bring the power before and minus 1 to the power and base differentiate panna. If I differentiate base, it will become 1. So 2x minus x minus h into 1 plus bring the power before and minus 1 to the power. Minus 1 to the power. If I differentiate this base, I need to differentiate y means y will become dy by dx. But in terms of x, I need to differentiate x means with respect to x. So this will become 1. D of dx. D of x by dx means it will be 1. D of y by dx means it will be dy by dx. So this is the thing. And then, so after that I need to differentiate again, right? So for this thing, first term I need to differentiate it. It will become 1 plus, you can see here uv. So start the formula. uv the whole dash, which is equal to u dash v plus uv dash, right? So this is u dash means y dash. Already this will become y dash and already a y dash is also here. So u dash v plus u, then v dash means y double dash, which is equal to 0. So I am just bringing these two things like plus 1 plus y dash the whole square. I'm just bringing these two things here, taking the minus outside and keep it as it. Okay, so you can see here y minus k, which is equal to minus of 1 plus y dash square by y double dash. Okay, here I need to tell one thing, that is like this h and k are the constant, a is not a constant. Okay, so just 2 derivative is enough. Okay, so I just done the second derivative here. After that y minus k, right? I'm just substituting this value here and finding the h x minus h. Is it okay? Yes. So I'm just substituting this value here. So it will become like this. After that, substitute all these two values. Means what? X minus h and y minus k. These two values in the original equation. After that, substitute all these things. Let me see that. I will tell you. You can see here. They have given. I'm just substituted x minus h and x minus k. Right? I'm just substituted those two values. After that, I'm just taking this y double dash here. So the fraction is gone. After that, you can see here this term and this term is same. So if these two terms are same means I can return these two terms as in bracket. How this comes? I am just putting plus 1 as extra here to bring this as a form. So I just bring this as a form. I got the equation. So this is the final equation. Okay. Solution of differential equation. Variables in equation should satisfy given differential equation. So the variables should satisfy differential equation. For the differential equation, they have given this one. d square y by dx square plus y, which is equal to 0. If I put y values, means if I put some functions to the y means this condition should satisfy. So for example, I am just giving y which is equal to a cos x plus b sin x means the second derivative of this plus y will be equal to 0. The same applies here. So I have given some functions. So these functions are the solution for this differential equation because these functions should satisfy this equation. Okay. So as I already told you, the solution is of two types, particular solution and then general solution. So, general solution means what? Many arbitrary constants that of order dE. There will be many arbitrary constants, but particular solution means what? Solution which is got from the general equation gives a particular value to the arbitrary constants. So, this solution gives a particular value to this solution, means to the constant, means it is particular solution. Okay. So, the first topic is first order or first degree of D dot E, differential equation. How can I write that? Dy by dx which is equal to f of xy, f of function, or m into dx plus n into dy which is equal to 0. So, we can write in both ways. Depending on f function, the equations are divided into 4 types. Variable separable form dE, homogeneous dE, linear dE, and then exact dE. Let's see the variable separable form of differential equation. First, we need to collect all the functions of x and dx on one side. So, variable separable, first we need to separate it, dx dy and dyy on the other side. So, it will be like a function of x into dx, a function of y into dx. If I need to put plus c like a constant, you can see here this is a differentiation. If I put integral means the differentiation will become, already we seen that differentiation of f of xy into dx function will be equal to d of dx of f of function into plus c. If I take differentiation means, if I take integration means the differentiation will become plus c. So, I am just taking integration here plus c. Okay. So, if I put integration means it will become the differentiation equation plus c. That's it. So, let us see some example here. They have given one question, y which is equal to y minus x into dy by dx which is equal to a into y square plus dy by dx. So, just multiply these things and then first separate it, dy dx. Okay. So, you can see here I am just multiplied it, and you can see here dx, but here there is no dx. So, just bring dx here. So, multiply into dx here into dx here. Like first I need to bring the y as in the same way, and then these dx in the another way. Okay. After that, take this dy by dx outside, then bring the dx here. So, I have separate all the things. Is it okay? Yes. After that, 1 by x plus a into dx which is equal to 1 by, I am just taking y as outside. So, after this thing, just 1 by x plus a into dx, this is a term. So, you can see here this is like 1 by 6. So, 1 by 2 3s are 6, right, which is equal to, I can write it as 1 by 2 minus 1 by 3. So, likewise I will write this as like this, 1 by y minus 1 by 1 minus ay. Here you can see here, how can I get here 1 minus ay? If it is a plus ay means I will get these things cancel, then I will get as 1. The same here. So, I need a here like this one. So, I need a here, right? So for this purpose I am just writing a here. Okay, after that you can see here this is in minus, right? So if I differentiate y means what will come? 1. Like you can see here, if I differentiate y means what will come? Y, 1. If I differentiate this term means what will come? Minus a. Just remove it. If I differentiate this means minus a y. If I differentiate this means the answer will be minus a, like here the minus a. So I can easily write log of y, because I differentiate this I will got 1. So log of y minus log e of 1 minus a, 1 minus a y, 1 minus a. So here if I differentiate this thing 1 will come, right? So take all these things as log and plus c is added. After that these are in minus, so I can write it as division. Okay, so this one plus c, which is equal to in the division form. After that I am just taking c as log k per base e. So if I put log here means these two are in addition, so I can write it as multiplication, which is equal to this term. So take the log, cancel, and this one is the answer. So the second one is homogeneous differential equation. dy by dx, which is equal to f of one function, f of second function, which is in divisions. These two functions are in divisions. f1, f2 are the homogeneous functions of same degree. If it is in same degree means it is called homogeneous. So the degrees should be same, right? Like the powers. So to solve it, the substitution method is used. Like you can see here, y which is equal to mu into x means if I differentiate this thing dy by dx, which is equal to mu plus x into d mu by dx. This is a term. Okay. So we need to separate the variables and then integrate it. Then we will get the values. Let's see one sum here. X square minus y square into dx minus xy dy, which is equal to 0. This is the sum. First I need to separate it, right? Just separate it. Bring this here. Okay. Yes. So this one is like I will tell you, x square minus y square into dx. I am just bring this here. This will be equal to this part, or else take this to here. So this will be equal to this part, xy dy, right? So this is the thing. After that dy by dx means this will come here, means this will come down. So this is the thing I have written here. After that dy by dx, so I have separated, and then I need to use substitution method. So y is equal to mu x, that is dy by dx, which is equal to mu plus x into d mu by dx. Okay, this is dy by dx, mu plus, just take it as uv. Okay, so u dash means x is 1 into v plus u v dash d mu by dx. This is like a u dash v dash. Okay, so this is a term here. After that, so these twos are equal, right? dy by dx, just make these twos as equal here, this one and this one. From these two equation I have written here, written this as follows. And after that you can see here, I just replace this y with y equal to mu into x. Just concentrate here. First we need to separate it. After that substitution method. In the substitution I have got one again equation like dy by dx, here also dy by dx. So I am just equating these two things, but in place of y I need to replace mu x. by replacing it I will get like this. Okay, so here x square will be taken as common and then it will get cancelled, so 1 minus mu square by mu will become, and this mu will go there like minus mu. So after simplifying it, I will get mu by 1 minus 2 mu square into dou mu d mu, which is equal to dx by dx. This is the thing at last one. After that you can easily integrate it. Okay, for that purpose I need to change this as log. How can I? If I differentiate, like you can see here, if f of x is a function, if I get f dash of x as in the numerator, means I can write this as, means if it is an integral, means I can write this as log e base f of x. This is the formula, right, for integration. So you can see here this will become 0 if I integrate it, if I differentiate it, and this term will become 4 mu, so I need to add 4 here, and this term if I differentiate x means it will become 1. So what I going to do means I need to add 4 here. How can I add it? 4 by 4. Here is minus, so minus of 4 by 4. If I add, so minus 1 by 4, the 4 numerator in the 4 will become inside, so 2 mu square. If I differentiate this means 2 will come before, power munadi varum. So if this power come to front means 4 mu, so 4 mu will come. So if I differentiate this, if I differentiate this term, I will get this term. Likewise, then I can easily write log of the denominator. So the log of x plus c. Okay. After that I need to replace this 4. So I am just multiplying everywhere 4, every term. So I have got this thing, and you can see here, just remove the logs. By removing logs means what? If the log has some anything on front, it will come to the power. So x power 4, I am just remove the log here, this term, which is equal to e power, because here are the logs, right? So I need to write e power minus 4c. Okay, and the very important thing is what? This is mu, right? So I need to replace this. So mu, which is equal to y by x. So I am just substituting these values. I will get k as this one. Means k is what? At last, up to this is okay. So I am just replacing this e part as k. So k is equal to this part. This is the answer. You can also write this e part here. There is no need to hesitate. This all or same. At last we need to we need to replace this mu. Okay, that's the thing here. And the another thing, this is like a non-homogeneous. Okay, so the non-homogeneous is reduced to the homogeneous form. How it is? If the equation is in the form like this, dy by dx, and they have 3 constants, ax plus by plus c by a dash x plus b dash y plus c dash, means we can reduce this form into a homogeneous form. But it follows 2 cases. Like the first case is what? A by a dash, which is not equal to b by b dash, means just substitute x, which is equal to x plus h, and y, which is equal to capital Y plus k. This is very important. You need to substitute these things for all the equation, for all the problems. So just differentiate these things. Dx, which is equal to d capital X, this will become 0, and the same applies here. K will become 0. Substitute these 2 things in the equation and substitute x, y values in the equation and substitute these 2 things in the left hand side. By doing so, dy by dx, which is in smaller letter, will become bigger letter. Dy by dx, which is equal to a into x plus b into y. I am just substituting all these values. After that, take a as inside, you can get ax plus by. I'm just returning here. Ah plus bk here plus c. So take the constants outside and just equate these two terms which is equal to 0. Then you will get hk value. Okay. After that, this becomes like this because after substituting c like k h values in this equation, means in this equation you will get a capital X plus b capital Y by a dash capital X plus b dash capital Y. So that this came here. After that, you can see here x y are in homogeneous. Okay, there is only one here. So after that you have to use the substitution method. So substitute it and then solve it. Case 2, a by a dash which is equal to b by b dash. If it is equal means just take it as 1 by m. These two things as 1 by m. So what is a dash? If I need a dash means m will come here. A dash will come here. Like you see, this one which is equal to a dash means a dash will come here and m will come here. A dash which is equal to m into a. B dash which is equal to m into b. Right? So after that I need to substitute these things in this here. Like a into small x plus b into small y plus c by, I need to substitute these things. A dash which is equal to m into a. So ma, mb. Take the m as constant. And you can see here this will come. So this is the first equation. I am just replacing these term as t. Means t. Okay. So take this term, y term here and then take the a term on the other side. After that differentiate because we need dy by dx, right? So we need to find this. So for that I am going to differentiate it. After differentiating it, you will get dy by dx which is equal to b, which is equal to like dy by dx into b. You can see here dy by dx into b which is equal to dt by dx minus a. This will become 1. So minus a. This is the thing. And dy by dx is what? 1 by b of this term. So this term is equal to this term dy by dx, right? Here also dy by dx, here also dy by dx. So just equate these two terms here. Okay, I am just putting t for these two complex terms. After that separate it. Okay, separate dx in a term and then dy in a term. You can easily solve it. Okay, then the next sum is what? 2x plus 2y minus 1 into dx which is equal to x plus y plus 1 into dy. So you can see here a by a dash which is equal to b by b dash. So what's the thing? Just bring this here down, means dy by dx, and this down here. This will go here and this will go here. So this is the term. Okay. After that take 2 as outside. So this term is like what? Like this. I am just taking the m outside, right? So like this it was here. After that I am just taking this xy as constant. So I am just substituted here. So what is the thing here? V which is equal to x plus y. You can see here I am just taking t which is equal to ax plus by. Likewise v which is equal to x by y, x plus y. So I am just differentiating it. dv by dx which is equal to x becomes 1 plus dy by dx. I am just substituting these terms here. Like you can see here dy by dx. I need dy by dx means dv by dx minus 1. So minus 1 which is equal to this one. So these two things. I am just taking dy by dx. After this just separate all these things. After simplifying, separate all these things, you will get the answer easily. So v by this one is what? V, right? I am just taking this v on both sides. So 1 by v, v by v. V by v is what? 1. And this one is what? if I differentiate v, it will become 1. So log of v here is 1. 1 is what? Integration of dv. Integration of dv is what? Only v, plus integration of 1 by v is what? Log v, which is equal to this thing. So we need to replace the v, right, because v is equal to x plus y. Just replace it and you will get the answer. Okay, don't need to put so many things here. Just check it is first form or in the second form. After that, continue with your work, like make the equation homogeneous. After that, substitute, use the substitution method. After that, separate it, then substitute the v again. Okay, let's see another sum. Dy by dx, which is equal to y plus x minus 2 by y minus x minus 4. Reduce it to homogeneous form. You can see here, this one is what? A by a dash, which is not equal to b by b dash. So I need to go for x, which is equal to x, capital X plus h, y, which is equal to capital Y plus k, right? So I need to find dy by dx. I am just substituting all these values in this equation. So it will become like dy by dx, which is equal to y plus x, right, in terms of y, plus in terms of x is x plus h minus 2. So this is the thing. After that, take x, y outside and the constants are in the same side, and by equating these two equal to 0, you will get h and k values, right? I have got k and h values. Substitute these two values in the same equation and you will get the linear equation, like you will get the DE equation, homogeneous equation. So the next thing is linear equation. What is this? If it is said to be a linear equation, means the differential equation is linear. If it is said to be linear equation, means only it should satisfy two conditions, like dependent variable like a, b, all these things. Dependent variables and its derivative should be first degree only. You can see here y dash, which has only 1 degree, y square by dx, dy by dx, only 1 dash, d square y by dx square, only 1 dash. Okay, and the next point is what? There is no product of dependent variable and its derivative. So the dependent variable and derivative should has 1 degree and these should not be in product. That's the thing here. So linear equation will be like d square y by dx square plus 3 into dy by dx plus xy, which is equal to x cube. And you can see here they have asked one question, which is linear equation. They have given 4 equations. So we know that the first thing is what? Differential equation is said to be linear equation only when the derivative and the variable should be in first degree and these should not be in product. So you can see here it has second degree, so this one will be cancelled. Here it was in product, so this one will be cancelled. Second degree, this one will be cancelled. Only 1 degrees and there is no product in it, so this one is correct answer. Okay, and there comes the gauge sum. The standard form of first order linear differential equation is said to be Lenz's linear equation. Lenz's linear equation. Okay, so what is the form of this equation? Means dy by dx, which is equal to p plus y. This is the form of the equation. Py, which is equal to q. So dy by dx plus py, which is equal to q. If it is in this formation, means you can see here this p, q or the function of x or constant. So I need to write the solution for this equation. The solution will be y into this part, e power integral p dx, that is integration for fraction, which is equal to differentiation, like integration into q value into RF, IF, integration part into dx plus c. This is the thing. So y into integration part, which is equal to integral pi into integration part into dx plus c. That's it. If it is, these things are for linear in y, these things are for linear of x. If it is for x, just replace the y with respect to x and x with respect to y. You will get the answer. So let's see some sums here. Q is, they have given the one question, x plus 1 into dy by dx minus y, which is equal to e power 3x into y 1 plus x the whole square. So I am just writing this term alone. These will go here like in divisions. Afterwards you can see here dy by dx plus py, which is equal to q. So p is what? Minus 1 by x plus 1. Q is what? This whole term. So I need to take the differentiation, integration fraction, like e power integral p dx, right? So p is what? Minus 1 by x plus 1. I'm just differentiating this, it will become 1, right? So minus of log e x plus 1. So log and e will get cancelled. This minus 1 will become to the numerator. So it will become as 1 by x plus 1. I have got the I value, if value. After that, what is the question? What is the general equation here? Y into if, which is equal to integration into q into if into dx plus c. So y into df, q into df into dx plus c. So as you know, substitute all these things and you will get the answer. And the next thing comes the Bernoulli's equation. What is Bernoulli's equation? The same as this one, dy by dx plus py plus q. But in q we need to add a new term, y power n. So this is the extra term, like, yes. So this extra term will come here. You can see here y term. So y power 1 minus n into e power 1 minus n into p dx. This is a long term, but this is easy in case of sum. Just if you see one sum, this formula will be very easy for you. Just see it for 1 mark questions. Okay. So after that, I am just replacing v with v, which is equal to y power 1 minus n. This is a substitution method. So I am just going to reduce the Bernoulli's equation to the linear equation. Okay. So let's see one sum here. They have given one sum, dy by dx plus py, which is equal to q into y power n. Just take the extra term here, extra term, and makes this term as in division. So 1 by y power n. I can write this as y power minus n, right? So multiply this term with each. So you will get the value like this. And then you can see here p has some extra term. So take this term and replace it with as z, right? Up to this is clear. Take the extra y term and make it denominator, make it in division to all the term. After that, take the p coefficient as z. So this is the differentiation of this term. Like you can see here, y power 1 minus n equal to z. Like I will written here, y power 1 minus n, okay, which is equal to z. This is the p coefficient. I have taken this as z, right? After that, we are going to differentiate it. Power முன்னாடி கொண்டு பவரில் ஒன்று மைனஸ் பண்ணி பேஸை differentiate பண்ணணும். See it here. I am just bringing this power in front, 1 minus n into this is the base, right? So y powerல ஒன்று மைனஸ் பண்ணணும். Need to minus 1 in the power. So 1 minus n minus 1. So this minus 1 plus 1 will become cancelled. So minus n will be there. And we need to differentiate the base, dy by dx, which is equal to, z is was what? dz by dx. So this is the thing. After differentiating this thing, just bring this term in the downward here, like in the denominator, you will get one equation. So up to this is clear. So I'm just taking the q coefficient and make it in denominator and divided it in all the terms. After that I'm just taking the p coefficient as z, and then I'm just differentiating this term alone. I will get the answer as this one. So you can see here this is the main equation, like put it as 1. This is a main equation. You can see here y power minus n dy by dx. So I have also found y power minus n dy by dx. So substitute this value in equation 1. So this is the equation 1. Okay. Sorry. So the equation 1 will become like this. So after substituting these things in the equation 1, it will become like this. You can see here this term, I am just replacing like this term, plus p into, what is this? This is z value, right? Because y power 1 minus n is what? Z. Y power 1 minus n is what? Z. So I am just putting z here. So this term I have got. And I need to make these terms to the front, because in between, before dy by dx, before the differentiation coefficient, there should not be any coefficients here. So after making this, the answer will become. So this is the answer. Just take the LCM, all these values, and you will get the answer. This is the linear equation. Let's see another sum to make it very clear. So x into dy by dx plus y into this form. So first one is what? I need to take the q coefficient. What is the q coefficient is? This is like q. And this is like p. I think p is 1 in this question. Okay. So q is what? Q is what? Y power 6. So I just multiply all the things by, divide by y power minus 6. And then I am just taking this x, because it is in front, right? I am just taking here. So this will become 1 by x, and this term will become y power minus 6. So making this in each term, you can see here. So y power minus 6. So multiplying it, y power minus 6 will come, and I need to replace this x to here and here. So this x will get cancelled. So only dy by dx will be there. Plus p is what? 1. Okay. And then they are already given y here, and I am going to multiply y power minus 6. So 1 minus 6, it will be y power minus 5. By, I need to bring this x here and here. So by x, which is equal to, if I bring this x here, means it will become x square into y power 6 minus 6, because we are multiplying it by y power minus 6. So this will become 1. This will become 1. So y power minus 6 into dy by dx plus y power minus 5 by x, which is equal to x square. This is the first equation. Is this clear? Yes. After that, I am just taking this one as p, like z. Okay. So y power minus 5 is equal to z. Like you can see here, what I am just taking the value p is 1, right? So here the p is 1. So I am just taking the y as a substitution method, z. So I am just taking here, p is constant, p is 1, and I am just taking this value as z. So after that, just differentiate this term. After replacement, just differentiate this term. It will become like minus 5 into y power minus 6, right? So we need to bring the power before and minus 1 to the power, and then differentiate the base dy by dx and then dz by dx. So this is the term. So from these things you can see here, this is common, like this one and this one is common. So just put it here, like just make other things to the left side, like this will become 1 means this will become like 1 by minus 5, right? So 1 by minus 5, I am just replacing these two things, this one and this one, these two equations. So just replace. This term will become like 1 by minus 5 into dz by dx. So this term plus here is what? Z. So z by x, which is equal to x square. So I am just written this equation here after replacement, and then separate it. Okay, and then separate it, and you will get one equation. Like you can see here, this is in front, so I am just multiplying each term by minus 5. So I will get here like this. This is nothing but the linear equation. After that, this is what? This is P, right? So this is like in this form, dy by dx plus P into y, which is equal to Q. The whole term is Q. So I have got the linear equation like this. Okay, so this is nothing but linear equation. After that, just we need to take this as integrating part, right? What is that? Integrating fraction is nothing but e power integral p into dx, right? So p is what? Minus 5 by x. So I am just taking minus 5 as outside. So this will become log x. And this minus 5 will become to the come to the power. Then this log and e will get cancelled. So answer will be only x power minus 5. So we know the equation, right? Y into integrating part, which is equal to integration of q into integrating part into dx plus c. So by substituting all these values, and you will get the final answer. Okay, let's see another sum here. This is the fourth one. Okay, in this thing, this is the last one. Extract DE. D is what? Differential equation. Exact differential equation. Exact differential equation means what? Exact differential of some function of xy. So we are exact differential. We are making the exact differential of some equation, some functions of xy. So this can be written as m dx plus n dy, which is equal to 0. So what is the differential equation of this term? Means d of differential of this function. Function contains xy. So differential of a function which contains xy. This is the differential equation for this term. So for example, if I am saying y into dx plus x into dy means, I can easily say the differential equation of x and y. Because you can see here x y the whole dash, which is equal to x dash into y plus y dash into x, right? So y into x dash like dx by dy plus x into y dash. If you make these things possible means, it will come like this one, this equation. You will get this equation. So x dash means dy by dx plus y plus x into dy by dx. So this is the thing here. So it is in multiplication. So uv, and if I take x y as c means, so I will get the c value like in the bracket. I am just taking this bracket as c. That's the thing here. After that, see another one, or else in the same one just divide it by 1 by y square, and you will get another function. In this function, you can easily say uv the whole dash is what? U dash v minus uv dash by v square. So just make these things and you will get the same equation. So it is the differential equation of x by y. So d of x by y, which is equal to 0. Then you can easily take this as constant c. Okay, just these two things are for your reference. Okay, so in general we know the equation m into dx plus d into dy, which is equal to 0. First thing is what? This is said to be exact means you need to find, you need to check the condition. Condition is what? Dou m by dou x, dou y, like m with respect to y and then n with respect to x. M with respect to y and n with respect to x. So by doing so, you can see here dou m by dou y, which is equal to dou n by dou x. It is said to be satisfied. This condition should be satisfied. Then you can directly write the equation solution as integral m into dx. It is somewhat a big equation, but this is dead easy in sum. You can easily put this as in the sum, but just read the equation because it may act in the 1 mark questions. So integral of m term y, take y as constant, plus terms of n independent of x. That is, you need to write the term of n but eliminating the x term. That's it. So integrating of n term and then y, which is equal to c. Okay, let's see some sum here. Solve y into sin 2x into dx minus 1 plus y square plus cos square x into dy, which is equal to 0. So before dx is what? M, and before dy is what? n. Include this minus also. So what is the condition here? M by dou y, and then dou n by dou x, right? So I am just differentiating these two terms with respect to x and y. Okay, so I just got the same value here. So the condition is satisfied. Okay, then if this condition is satisfied, I need to take this equation. Equation is what? M. I need to write the m. I just wrote the m, and here this y is, I should take this y as constant. That's why I'm just writing this here. And then plus terms of y. What is the n term? Sorry, term of n. What is the n term? Minus of 1, minus of y square, minus of cos square x. Cos square x should be omitted because this is x term. So I am just writing minus of 1 plus y square alone, which is equal to c. So just integrate it. If I integrate sin 2x means it will become as minus cos 2x by 2, right? After that, integrate these terms and just write it as in a single term. You will get the answer. That's it. And let's see some grades sums. The necessary and sufficient condition for differential equation of form, they have given m and n. They have asked the condition and they have given the form. What is the condition? Dou m by dou y and dou n by dou x, just the opposite thing. So this is the condition. And the next sum, if c is constant, then they have given one solution is this. Just this is a solution. Solution means the separate dx and dy here, and then take integration. If you are taking the integration means plus c, because this is differentiation. So if I take integration means I need to put plus c in the x term, right? So what is the tan inverse value? Tan inverse is nothing but 1 by 1 plus y square. This is a integration formula. Integration of 1 by 1 plus y square is what? Tan inverse of y. So y is equal to what? Just take it, just put y alone here. Take the tan in here, tan of x plus c. That's the answer. And then biotransformation of an organic compound having concentration x can be modeled using an ordinary differential equation. Nothing but they have given one equation. They are saying this k as reaction constant, and they want us to find x equal to a at t equal to 0. So first we need to separate all these things, and then you will get a equation like this, and then substitute these values. We'll see that. First, this is the equation. So I am just taking this as here, and minus will be here, and then I am just separating these things. So this x square will come here, and this dt will come here. I am just taking this minus also. After that, I am just integrating it. If I make an integration means I have to add plus c here, and then I just integrate it. I just got the equation. After that, substitute the value, you will get the answer. So substitute x equal to a and t equal to 0, you will got the y c answer. Okay, for the constant c, and substitute this c value in this equation 1, and you will get the solution. So it is dead easy. Okay, let's see another sum. The solution of DE, they have given one solution and they have same thing. Just separate it and make the integration. If you integrate it means just add plus c here, and then you can see here 1 by x is what? Log x. So 1 by y is what? Log y. So after that I just need to remove this log. So I am just bringing e in each term. E part this whole. Okay. So the log will come here like e part x cube by 3 plus c. So just take e for these two terms. After that you need to apply these values in this equation and you will get the value for c. E power c is 1. So you will get the answer. And then next question, consider the differential equation. They have given one equation and they have given the they have given one point and they want us to find this point. Here is what I will say that here. First separate the equation. Okay, but here you can see here this equation is in the form of dy by dx plus py plus q. So we need to find the integration part, right? Because q and so what is p here? 1, q here e power x. So I am just taking the integrating part, and you know the formula y into integrating part, which is equal to integration into q into integrating part into dx plus c, right? So integration is nothing but e power x. So y into e power x, which is equal to qx is also e power x. So e power x, e power x, e power 2x. Okay, this two term will become e power 2x into dx plus c, right? So just differentiate it, e power 2x by 2. Okay, plus c. Is this okay? Yes, it's okay. So I'm just differentiate these things and I'm just gonna apply the points. What is the point they have given? Y of 0 which is equal to 1 means this is y of x. Okay, so y of x equal to 1, y is 1 and x is what? 0. So this the points are like x which is equal to 0 and y which is equal to 1. So substitute those points here, you will get the c value, substitute the c value here and you will get the equation. After that you need to find y of 1. Y of 1 is what? X equal to 1. So substitute the value here and you will get the answer. And then like another two more sums are here, and this is a gauge sum. A system described by linear constant coefficient ordinary first order differential equation. So this system is described by linear and constant coefficient ordinary. Okay, linear constant coefficient ordinary first order differential equation has given an exact u solution. So they have given this as exact solution. Okay, y of t for y greater than 0. When the forcing function is x of t means, if the forcing function is x means and the initial condition is y means, when this function y of t becomes minus y of t of minus 2y means, what is this two condition? What is this two function, this forcing function and this initial function will become? Just easy, you can easily say if this is multiplied by minus 2 means is these two things are also multiplied by minus 2, but you need to check. So y of t which is equal to, they have given one part like this is like a formula, nothing but we know that y into, you can see here this is a formula, y into integration part which is equal to we know this formula, right? Integration of I into q into integration part into dx plus c. So I am just taking this integration as 1 by 1 integration part. That's the thing here. Just they have add x of t, y of t because it is a function. So they have add some function. They said that this function is forcing function and y is initial function, initial chord, like initial condition. Okay, just multiply minus 2 here and you will get these two things also multiply by 2. So you can easily say the forcing function changes to multiply minus 2 into x and the initial function, this is not a function actually, this is condition. So the initial condition is also termed as minus 2 into y. This is condition. And then the general solution of DE, they have given one solution with constant. So let's take, because this is a complex term, so I'm just taking x plus y as t. I'm just differentiating this term and I have got dt dx minus 1, like this term here, minus 1, which is equal to, sorry, I'm just differentiating this, up to this is okay, and then I'm just considering these two things, dy by dx. I need dy by dx, which is equal to dt by dx minus 1. So I just put here, and then you can see here cos of t. So I just put here. So this one will come to here, and you know that 1 plus cos theta, which is nothing but 2 cos square theta by 2. So I'm just writing this formula here. After that, just take dt here and take all this term here, and then take dx here to the numerator. Okay, I'm just taking dx to the numerator and taking these part to the denominator. So 1 by 2. So this 2 will become 1 by 2. And cos square t by 2, that is secant square t by 2, right? Secant is what? 1 by cos. So I am just writing this into dt, which is equal to dx plus c. Nothing. So after that, taking 1, just take 1 by 2 as outside. This secant square theta by 2 is nothing but tan theta, right? So 1 by 2 into, I'm just integrating this. Power முன்னாடி கொண்டு the base differentiate பண்ணும். Like if I differentiate this, secant square theta by 2 means 2 secant, like if I differentiate this means it will become tan t by 2. That's it. So that's the thing came here. 1 by 2, 2 power முன்னாடி கொண்டு the base differentiate பண்ணிருக்கேன். So 2 into tan t by 2 into dt. Okay, so we need to put this because we have already integrated it, which is equal to x plus c, because dx, so x plus c. After that, I'm just taking this tan here and this will become 1, right? So I'm just taking tan alone, and then this is a term, just replace this t and you will get the answer. So up to this linear equations, so the first order linear equation, all these completed, and we will see the next one, like the higher order differential equations will be seen in the next video. Thank you. Bye bye.